In this lecture, we're going to talk about the digestion of carbohydrates and proteins. So we start off with carbohydrates. They must be broken into their monomeric parts, and the only monomers that our body actually recognizes are galactose, glucose, and fructose. You notice that OSE at the end indicates that it is a sugar or a carbohydrate. Now, the enzymes maltase, sucrase, and lactase are able to break down maltose, sucrose, and lactose. And that allows us to go from our disaccharides here into our monosaccharides. So each of these, lactose, maltose, and sucrose, are disaccharides that just have to be broken apart into their final monomeric parts. Before we get to the disaccharide level, though, oftentimes we have much larger structures that have to be broken apart by other enzymes. Salivary amylase helps to break apart the complex carbohydrates in the mouth, especially starches. And pancreatic amylase helps to break apart carbohydrates in the small intestine. Additionally, there are some brush border enzymes such as dextrinase and glucoamylase that are secreted by the brush border in the small intestine and then go to work on these larger sugars. Lactase, maltase, and sucrase are also brush border enzymes. So you have the final breakdown of these sugars right there, right where they're going to be absorbed. Now, carbohydrates are going to be absorbed into the bloodstream. Let's see, where are we? I think that's all part. So the absorption, is over on this side here. Carbohydrates are going to be absorbed into the bloodstream either by facilitated diffusion or by active transport, and oftentimes this is going to be combined with a protein carrier. When we take a look at proteins, proteins are broken apart into their monomer, which are amino acids. In the stomach, this is accomplished with the enzyme pepsin, which is a little bit of an unusual enzyme because it's able to work in the very acidic atmosphere of the stomach. Most enzymes can't work in very acidic conditions, but this is one enzyme that actually prefers them. In this, let's see, the pancreas secretes trypsin and chymotrypsin, and these are able to break down larger proteins into smaller parts. And then there are several enzymes that are secreted by the brush border of the small intestine itself: carboxypeptidase, aminopeptidase, and dipeptidase. Now, carboxypeptidase will take smaller strips of, it will take smaller little strips of amino acids that are still tied together. Carboxypeptidase works from the carboxyl end, and aminopeptidase works from the amino end of the line of amino acids and breaks them apart that way, so kind of eating away at either end. Now, proteins are going to be, proteins are going to be absorbed, proteins are carried into the bloodstream, often coupled to sodium transport. And so sodium is a positively charged structure, proteins are generally negatively charged, so this kind of balances, and that allows us to eventually work our way through the columnar epithelium of the villus and eventually directly into the bloodstream. Whole proteins are very rarely absorbed unless, with very newborn babies, whole proteins are apparently able to be absorbed because babies are actually able to take in proteins through their digestive system in the form of immunoglobulins or antibodies. So, of course, babies are able to pick up antibodies in breast milk, and they're able to absorb the entire whole protein into their system. We don't actually know exactly how this takes place, but we think it's because the lining of the villus is not quite intact yet, and so whole proteins are able to be carried across, whereas with most people that is not the case. Whole proteins should not be absorbed, in fact, because if you're absorbing whole proteins, your body's going to react against them. Some of the worst allergic reactions are the ones that take a couple of hours to show themselves, because what's happening in that case is that they're actually going in straight through the sides of the intestine. There's something about whatever allergen it is. I think peanuts are one of them that is capable of this. And they're able to, the proteins that are found in the peanut are actually somehow able to traverse through the sides of the villus and into the bloodstream, and there the body recognizes these whole proteins and will attack them, and it can be very disastrous for the body.